Okay, as we look to set up here 115, this has kind of got a lot going on in here in this problem. We're pedaling the pedal. Obviously we all experience this riding a bike. The pedal is attached to a spoked wheel that has a radius of 4.72 inches. That drives the back wheel with a radius of 1.38 inches. And then of course that gear on the back is attached to the tire of the bike, which the tire has a 13.6 inch radius wheel. So the question is, if we rotate the pedal halfway around 180 degrees, how far does that actually take us on this bicycle in this gear setting? So it sounds kind of complicated, and maybe it is for a little bit, but I think if we apply the formula we know, S equals R theta, we can definitely get this done. Like in the previous examples, the arc of the bigger gear will need to be found, and then really that's like the arc of the little gear in the back, but obviously with many more revolutions taking place because of the same distance, smaller gear. So let's see if we can't get something set up to figure out the arc of the bigger gear. The arc of the big gear would be, of course, the formula S equals R theta. We are searching for S. We know R is 4.72 inches. And the angle is, like the last problem, 180 degrees. Well, this one's easier to convert because you just know it. 180 degree turn is pi radians. So we can't put degrees into the formula. So if we do the math on that, we find out that 4.72 times pi is approximately 14.83 inches. So with a half a turn of the pedal, the front gear turns 14.83 inches. Well, in the back part of the problem then, in the end, that little gear is going to have to travel an arc of 14.83 inches. So again, I'm going to take 14.83, and that is the arc it's going to have to travel. Its radius is 1.38 inches, and what we're searching for here really is the angle that will turn. So we'll divide by 1.38. So that back gear is turning now 10.75 radians. And now what basically that amounts to is we wish to come up here and find out how many revolutions, or how far you get, I should say, with a turn of 10.75 radians on that small gear back here, but it's driving the big wheel. So it's just one more time through the S equals R theta formula. This time we want to know the distance we go, S. We know the radius of the big tire is 13.6 inches, and then the angle is 10.75 radians. So if we multiply there, 13.6 times 10.75, we can come out of that with 146.2 inches. To the nearest inch, that kind of covers your basis through all the calculations. If you round it a little different along the way, you should probably all come up with 146 inches of travel.